In this video, we'll be using law of cosines again, but this time to solve for missing angles. You do this when you're given all three sides, so side, side, side. And I'm going to use the same formula as before. So if you're solving for an angle for this one, so just because I want to use the same formula, you can call that angle big A, and then little a will be the one across from it. And then B and C can be the other two sides. So let's go ahead and write our formula down so we know what to plug into. So here in problem 1, they want the measure of angle C. So we want this angle. This is going to be my angle A. And then that goes across from little a. So B and C can be the other two sides. So A squared would be 21.6 squared. B squared would be 24 squared. And then C squared would be 26 squared. And then my cos would be angle A. This time we don't know it. So we're finding the angle. We don't know it this time. So our steps are going to be a little bit different. I'm going to start by chunking all the squares and figuring out what those are equal to. And then this part here I'm going to chunk as well. So I'm going to start with 21.6 squared. Squared comes out to 466.56. 24 squared comes out to 576. And 26 squared comes out to 676. Then I'm going to do 2 times 24 times 26. That comes out to 1248. And then I'll put the cos A after it. So what I'm going to do is I'm going to start moving some of these things together. Here I can add these. That comes out to 1252. Now, here, I don't want to do 1252 minus 1248 because that one's stuck to the cos A. So what I'm going to do next is I'm actually going to get rid. I'm going to start moving stuff away from the cos A. So I'm going to start by getting rid of the 1252 by subtracting it from both sides. That comes out to negative 785.44. Here they're multiplying, so the opposite would be to divide the negative 1248. If you divide those, I'm going to give at least 3 numbers, so 0.629. So 0.629 equals cos A. So now we're almost done. We don't want A, not cos A. So we want to move the cos to the other side. When you do that, you do the inverse. So instead of cos, it's going to be cos negative 1.629, and that'll give us our answer for A. So I did that on a calculator. That comes out to about 51.0. So A is 51.0. So here in my picture, this angle be about 51.0 degrees. if you look at our next picture, we're going to continue with these steps. So here they want the measure of angle R. That's this angle here. So I'm going to call that big A. And that is across from 59.7. So that's going to be my little a in my formula. The other two sides can be my B and C. So I'm going to plug into the same formula we've been using. So for A squared, 59.7 squared equals B squared plus C squared minus 2BC cosine of the angle A. And we don't know that one yet. That's what we're solving for. So I can start to chunk this into pieces and make it smaller. So I'm going to start with 59.7 squared, and I'm going to put that in a calculator. That comes out to 3564.09. Then 52 squared comes out to 2704, and 41 squared comes out to 1681. I'm going to do 2 times 52 times 41. That comes out to 4264. And that would go in front of the cos A. So now I can add these together. And I get 4385. So here's where we're going to have to start to solve. We can't do minus on the right hand side because the cos A is stuck to that second number. So we need to start moving stuff away from the cos. So I'm going to get rid of the 4385. So on a calculator, I would do 3564.09 and subtract it from the 4385. That comes out to negative 820.91. Now I'm going to divide by the negative 4264. That comes out to, if I use 3 digits, about 0.193. So that's equal to cos A. And then just remember to finish up, we don't want cos A, we just want A. So I would move cos to the other side, but then I get inverse cos. So in my calculator, I'm going to do cos negative 1, or inverse cos of 0.193. And then I'll round my answer to the nearest tenth. So this one comes out to about 78.9. For that big angle A that I labeled in my picture, which here is my angle R that they were looking for. So that's about 78.9 degrees. So we're using the same formula as the previous lesson. The only difference is this time, what you're solving for is not by itself on one side of the equation. So at some point, you're going to have to start moving stuff over and solving